Okay, I'm Aleksandr. I'm a Scala Plugin for IntelliJ IDEA team leader.
Yay!
And today we will talk about Scala Plugin and probably a little about Scala in general. What I want to say, probably for those who still uses Eclipse, some kind of advertisement. Sometimes when people learn something new, they still do the same patterns as they usually do. And do you think, is it Scala?
Not idiomatic Scala.
Yes.
Pattern matching.
Yeah, of course, pattern matching is much better, isn't it? But when you come from Java, you usually do the same patterns as you used in Java earlier. And how to stop your growing team from writing such code as you saw here? And actually, simple answer is very, very simple. Just use IntelliJ. And IntelliJ is able to show you that this code is not Scala code, and you can, in one action, just convert it to pattern matching. This is how inspections in IntelliJ IDEA works. I mean that IntelliJ sometimes tries to learn people to write better in their favorite languages. This is how it works in Scala. So, okay, let's start to talk about Scala plugin features. First part will be about these things. Second part, okay, probably should move a little. Okay, thank you. Second part will be about Scala plugin sources. So probably somebody wants to extend it or probably help to fix something. And third part will be about upcoming features, our roadmap. I want to show you our nearest roadmap until December, when we are planning to release IntelliJ IDEA 13. Let's start to talk about from auto-completion feature. Auto-completion feature is very simple in using. Basic auto-completion is what you use every day because of auto completion in IntelliJ. But there are actually three types of completion: is basic completion, smart completion, and global completion. And I want to tell you about all these three types. Sometimes some completions are very simple, so you just call and use it, and you don't need to know about these features. And some completions you need to know exact places where you can use it and to use it in these right exact places. Just don't to forget about it. So let's start from basic completion. This is very simple. It just collects all possible symbols for current cursor position. So if position is for expressions, so it collects all expression symbols like values, objects, and definitions. And if this position is type, then it collects all type symbols and also singleton symbols like objects and values. For singleton symbols, it inserts dot automatically, so you don't need to care about such things like dot or parentheses when you complete method. And even for method completion, you don't care about such things like getters from Java, because everybody, probably most of us know that for simple getters from Java, we don't have to use parentheses. It's better to avoid them because this code usually don't have side effects. So to mark that this code don't have side effects, we just need to avoid using parentheses. So IntelliJ can understand this pattern as well. So when you complete simple getters from Java, it just doesn't insert parentheses. Sometimes we use basic completion for information. So we want to extract some information from context. So we just invoke basic completion and look through the whole list. Actually, in Scala, it's less usable because Scala completion list is very big because of a lot of symbols in scope. So that's all about basic completion. It's very simple. But what I want to tell you is a new basic completion feature. It even not released yet. I hope it will be released next week. So let's see how it works. This is completion for constructor parameters and for super method calls. So when parameters of super constructor have the same names as our constructor and the same types, we usually want to just put them in the same places, in the same parameters. So here we probably want to complete string, comma, integer. So we can just invoke completion type and choose string integer completion variant. For super methods, we can do the same thing. So here we can choose string, comma, boolean. And this is very useful, and we don't need to invoke completion 2 times, and it's much faster and more productive in your development. So let's start to talk about smart completion. What do you think? This is simple illustration about smart completion. What do you think? What we can put to this place? Who can tell me? It's actually a very simple question, but IntelliJ IDEA can answer you this question in a second, even just less than a second. So
at this point, I would press Control Space or whatever it is.
Control Shift Space, actually.
And then get help from you on it.
Yeah, yeah. So, okay, the answer is very simple. Sum of E2 point project. Actually, you need to invoke smart completion twice because it includes chain completion, which is not available in first smart completion. So you should know when you want to invoke chain completion, you need to try smart completion twice. So smart completion is such thing which filters out from basic completion variants such variants which are definitely wrong. I mean that if we need string type and some function returns integer type, then probably we don't want this function in this place. So if we don't want to write some chains, we can just call smart completion and choose some variant is from smaller list. And there are some more very effective features of smart completion, like chain completion. This is second smart completion. You saw on previous slide that we completed E2 point project. So if project is not available in scope right now, it's sometimes available from another variable, and you don't need to search it which variable have project's function which returns project. You can invoke second smart completion and choose right one. I use it sometimes also for information, just to search is some symbols like project available in chain. So we can discover such things. There are also some completion. You saw here some completion right here when expected type is option and we have not option variable, we can complete some of this variable or definition. And there is also factory method completion, which can complete. If we search some type, we usually have factory methods in companion objects of this type. IntelliJ can search among these companion objects and try to figure out which method is compatible here in this place. So, for example, if your expected type is hash set of integers, so you can invoke just smart completion and get hash set.empty variant, which is cool. And there is also a very useful feature like generate anonymous function. So when expected type is function and there is no any prefix for completion, I mean some identifier or something like this, you can just invoke smart completion and to generate some boilerplate stuff which IDE can infer from context, and then just type body of this function. I can show you a short demo. So here we can see that a fold left invocation which requires a function. So we can invoke just smart completion here, put names, and just fill body of this function. This smart completion is actually knows about special braces syntax. So if you use builder's syntax, for example, for fold left, we can invoke it and just get case variant. That's how it works. Also, this can sometimes we cannot infer types from expected type. So in this case, generate anonymous function suggests you to define type for parameters. For example, I can invoke it here. And right now it shows like nothing type. I defined integer, then define type, and then I can write body of this method, for example. So that's very simple and useful to generate some stuff, especially when you have more than 2 parameters, so you don't need to write them by yourself. And third type of completions is global completion. This type of completions requires some import to get it compilable for this completion variant. From IntelliJ IDEA 12, it's the same thing as second basic completion. I mean that before we had different shortcut for global completion. It's Control-Alt space. And now this shortcut is actually the same thing like double control space. So you can use double control space or you can use Control-Alt space. It's the same thing. And even more, when basic completion can't find any applicable variant, I mean that prefix doesn't match for all variants, IntelliJ starts to search again with global completion. So sometimes basic completion works even for the first invocation. So it also works for auto-pop-up completion. So which features global completion has? There are some effective features. First of them is class and type aliases global completion, which probably every user of IntelliJ IDEA use extensively. But type analysis completion we added recently, and probably it's available only in the latest release of Scala Plugin. So this is quite simple. So it searches just among all classes in project and all type analysis which are available from some static context. So it's type analysis in package objects or objects. There is also functions global completion, which you can use when you don't remember in which object this function is defined. For example, you remember some name of this function, then you can just type this name, invoke global completion, and IntelliJ searches among all static functions in all objects and search which function name are applicable to this prefix. This is very useful. So you can use it, for example, for scene or something very similar things. And we also have implicit conversion completion, which I show you right now in action. So here we can see integer and dot, and I want to write something like this. Call this method, which calls import me. But import me is not available in integer. We need to import some implicit conversion to extend integer type. So you can see here some class which have this import me method and object with appropriate implicit definition. So how it works? You can just invoke global completion, and when we write some prefix, which we can see completion variant like global completion dot import me, and just invoke, and that's all we need to do. Okay, so this is all about completions. You just need to know all types of completion, all features, to use all of them more productively, and it's very good to know them. Okay, next feature I want to show you is type info actions feature. Type inference sometimes requires more attention because not only from compiler or from IDE, because you read this code and you need to understand which type exactly has some symbol, and this type is not available in source code. In IntelliJ, you can just ask information about type, and there are two options for this. One of these options is on demand, so you can just invoke some action and ask about it. And second option is using by your mouse, just put caret over the symbol, and you get pop-up with type of this symbol. In IntelliJ IDEA is actually keyboard-eccentric IDE, so we want to teach people to use only keyboard for development. So that's why mouse hovering type info action is disabled by default, but anybody who wants to use it, still use mouse, can enable it and use it for getting type info. So let's see this example. Who knows which type case you will have? Actually, this is also a very simple example. Not seek of int.
What is group 2?
Hmm?
Group 2, what does that do?
Just group by two elements.
Oh, so it takes the sequence and puts them in groups of 2?
Okay, let's see this. It's iterator of int. Is it simple to understand? Actually, you saw that it's not really simple. So sometimes we need such features in IDE. And also for this action, we can select any expression and check type of this expression. So this is the place where you can understand where iterator started to exist in this chain of calls.
See, I would do extract variable on that selected part and then do Control J on the
variable
to see what it was. I didn't know what
So some people said that
Only do it on the reference, get the type, but not on the definition.
this action have alt equals shortcut, but I can tell you that in IntelliJ you can simply discover shortcuts by using go to action. So go to action is Ctrl+Shift+A. We can invoke and just type name of action, and to see here shortcut or even invoke this action. Here this action is not applicable, but for example here we can invoke it. It's not working for type and for action works. Okay, but we still can discover shortcuts using type and for using go to action. I mean, you can forget some actions, but you can remember name of this action, and so you can just discover it.
What about getting the API help for grouped?
API what?
Do you offer something to bring up the API document for grouped, for example?
Yes, but
the whole thing, the words that describe what it does.
There is no any information in documentation. Because what's going on? I just.
We won't have to worry about that. I don't want to.
Shift-I is an interesting one.
What is it?
It's the implementation.
What?
Command-Shift-I.
Is go to action. Command-Shift-I is. I just didn't attach sources to this project, so documentation is not available here right now.
You would go to the source and just look at that.
Yeah.
Just F4, is that the same thing?
No, it's action
Show quick documentation pop-up, it's called.
quick definition. It's Control Shift I.
That's what you were talking about, but there's also, in addition to Control J, there's a Control Shift I, which will just pull up the implementation in that same little box.
Oh, it'll pop up a little window.
Yeah, that's a command I use sometimes for that.
That's
So we can write some documentation to show you how it works. For example, we can call this method, and right here we can invoke documentation pop-up and read it and write in pop-up. You can see this some documentation. It even understands the wiki syntax, so for wiki syntax of wiki syntax. Yes. Do you know it? So you can just use, for example, some kind of this. Okay. And here invoke and see documentation underlined. This is how works Scala doc tool. I mean, generating web pages for Scala documentation. And also, I want to show you mouse pop-up. You can put it here, show type info on mouse motion with some delay. Delay is also configurable. So then I can just put mouse here and get information about type. I can put mouse for any definition, even here, and see type of B pattern. Okay, what's next? Next feature I want to show is go to implicit conversion feature. Sometimes we know that this expression is converted, but sometimes we want to see which implicit conversion converted this expression to another type. So we can just invoke this action, and to see the list of possible implicit conversions for this expression, I mean, these expressions have some type, and for this type we search all possible conversions, and this list contains all of this. And also a bold font has actual implicit conversion which was used, and this is pre-selected when you invoke this go to implicit conversion action. Also, this list is separated into two smaller lists. First is implicit conversions from scope, and second list is implicit conversion from extended scope. Extended scope also collects implicit conversion from companion objects of our types. I mean that expression type and type to which we want to convert. Even more, we even can choose any of these implicit conversions and to make this implicit conversion explicit. So sometimes we probably see that a wrong implicit conversion were used, and we can just invoke this list and choose right one and make it explicitly. Okay, what's next is show implicit parameters feature. So it's similar to implicit conversions feature, and actually I want to join them together because they should work in very similar way. When implicit parameters were added implicitly, we can just invoke this action and to see list of actual implicit parameters, and even navigate to any of these symbol.
Would that work in a for comprehension where you don't see the method call? Would that work in a for comprehension?
Is it work for comprehensions?
Yes, because there's no method you could navigate on. You just have the comprehension, but you don't see the actual flat map or map.
I'm not sure that it works for comprehensions, so probably I'll check it. Actually, I want to invest some time of joining together implicit conversions and implicit parameters. I mean that, for example, you got implicit conversions lists, and some of implicit conversions also can be some implicit parameters also can be added implicitly. So we can extend this recursively, this feature. So I think that I'll check for comprehensions as well. So this is some kind of puzzle. This is not related to Scala plugin. You can see this example. It's about implicit parameters, which here they are passed explicitly, and on the next slide they are passed implicitly. So I show you just first one. Question is which of these code examples actually compiles and which of them doesn't.
But please don't say again that it is easy.
It's not easy.
Okay.
Actually, this one is not easy.
Okay. Because you hurt my feelings before.
Sorry for this. Okay. So here we have map function with two generic parameters and two implicit parameters. First of them is array of t, and second is a builder of t and r. And we want to return r. So we have two implicit values. First is just array of integers, and second is builder of t to t. So why not to pass them implicitly or explicitly? So I can make some small poll. Who think that these two examples compiles?
Can you show the other one again?
Hmm?
Can you show the other one again?
other one, it's the same, but parameters passed explicitly, implicitly actually. So nobody wants to participate in poll.
No, I think they both compile.
Okay.
I think the second one compiles.
Second one compiles, and first one?
Probably not. I think it'll infer nothing there.
I'll say
Okay.
it needs parameters.
What?
Explicit. I'll say it needs them explicitly.
So explicit. Okay. Answer is that explicitly passed parameters doesn't compile and implicitly compiles. The answer is okay. It's not easy. Here you can see that we want to pass x, which has array of int type, so we can infer that t is integer. And second type has builder of unknown type, and we want to put it to t and r. But from first parameter, Scala type inference works in such a way that we cannot infer from other parameters in the same parameter clause. So we don't know any information about t yet. So in this case, for builder, we can infer also nothing type. So here we can infer that builder has nothing type. And here we can see that t also should be nothing. So compiler can't compile because t should be nothing and int simultaneously. And for implicitly passed parameters, Scala works in such a way that every parameter is like a single parameter clause. So firstly, we can find implicit parameter x and infer that t is integer. And then in builder parameter search, we use this information about that t is integer. So here we can infer that t and r is actually integers. This is actually my almost new discovery about Scala language. I was slightly surprised by that implicit parameters passed explicitly can sometimes not compile. But algorithm is really simple, so that wasn't really a big problem to implement it in Scala plugin. So let's return to Scala plugin features. This is collections inspections. It's very similar to the first one I showed about is instance of and as instance of. Sometimes, especially when we learn collection API, which contains more than 100 different functions, we can't learn all of them. So in these cases, we sometimes can help to reduce and to learn new functions. So who can tell me how we can replace this call?
I think there's a count.
Yeah. So IntelliJ also knows that it's count
I'm sure
and
it does.
suggests you to replace. And also for all inspections, you can run inspection on whole your project repository and to check this inspection and even fix all of possible problematic places.
And how dangerous is that to do?
It's not dangerous. You can fix them and then on commit just review all of changes and see that all of them are that all of them are right actually. Also, I want to tell you about string conversions, which is very handy to when your code started earlier than, for example, 2.9, when we didn't have interpolated strings. So you can just, for string concatenations, invoke intention and to convert into interpolated string. So I, for example, sometimes discover such places and want to replace it to interpolated string very much. So IntelliJ helps me a lot. New feature in IntelliJ IDEA is new refactoring, which called introduce field. In Scala, this name is wrong because in Scala it's introduce property should be called, but this name is inherited from in general IntelliJ IDEA. So let's take a look how it works. Actually, this is quite simple. Just can invoke, ask to replace, for example, all occurrences in this class, and just call it. So we can see that we introduced new field and replaced all variables, all places of this expression in this class. So it's similar to introduce variable, but it can introduce to class level. That's why we, for example, change introduce variable on class level. It also generates private value. I mean that when you develop on constructor level, so you also probably want to use introduce variable, but it shouldn't be a field, so we changed it to generate only private values. Also, almost new feature is generation of companion objects. So earlier in Scala plugin you have had an option to type manually object or class, and then for name use basic completion. It searches among neighbor classes, collects their names, and suggests name for new created object or class. But now you can just use generate action, alt insert, and generate companion object for any of classes. Also in IntelliJ IDEA 13, it's available generation of equals hashCode methods in truly functional style, and I can show you. This is actually the first difference between IntelliJ IDEA 12 and IntelliJ IDEA 13, because we needed some changes of platform which are available only in IntelliJ IDEA 13. So we can just invoke generate action, choose equals and hashCode. Here pre-selected only values because it's not really good idea to generate equals and hashCode for variables. Then we can choose it and get truly functional equals and hashCode and can equals method. Okay. And another cool feature in IntelliJ IDEA 13 version is rearranger. So we all know about reformatter feature, which can keep your code formatted very well. But also in IntelliJ IDEA 13 plugin, we will have rearranger feature. It will be available from next available version for IntelliJ IDEA 13. So let's keep class members in order. You can see here rearranger demo with complete mess of members. So we can see type, private type, value, definition, value, private definition, and so on. And now we can just invoke reformat code, pick up rearrange entries, and get everything in right order. Types and private types, values, variables, definitions, classes. And also any order is configurable, so you can choose what you want and how you want to keep order of your members. I also want to tell you about Play 2 plugin, which probably you use. Who use? Only one? Two? 4 people, great. Now we have templates and roads highlighting in IntelliJ plugin. Also we have instant code assistance, so you don't need to recompile your project to get some binaries and then infer code assistant from binaries. We have in Play 2 plugin just instant code assistant, which based on sources, not on binaries. We also have rename, find usages, and quick navigation, and all this stuff for everything from templates and roads in Play 2. And of course, we can everything inherited from IntelliJ Ultimate Edition, which have JavaScript support, CoffeeScript, CSS, LESS, and Emmet. What we want to implement in IntelliJ 13 version is SBT integration. When you will not need command line for Play framework, just use our SBT integration to generate project files, to keep them synchronized between SBT build file and IntelliJ project file, and so on. That's what we have with Play 2 integration. And now let's talk about Scala plugin code. The first thing is that it's simple. Actually, in general, Scala plugin is sophisticated thing. It have a lot of not simple things, but most of parts are really simple and requires very basic knowledge to start any development. So if you need some feature, you probably can extend Scala plugin, and it can be really simple. It has convenient API. Everything starts from lexing and parsing of your code, then building PSI tree over your parser tree. PSI tree is program structure interface. In IntelliJ, we can merge PSI trees on any changes. So when we change something, we can generate new PSI tree and then merge it with old one to keep classes, not to regenerate a lot of PSI elements. So you can keep some caches in these PSI elements and then analyze it. Okay.
PSI, is that a term from computer science, or is that related to the plugin? That's
Yes.
a well-known.
Yes.
Okay.
Analyzer is based on PSI tree, and everything else is based on analyzer. What is PSI tree exactly? It's just structure. It's representation of every syntax structure. So, like if you have if statement, for example, then it have a proper interpretation, representation in PSI tree, like if statement element. You can navigate to parent elements of PSI element, to children, store some caches. You can even change elements, so you can, for example, say to IntelliJ replace child, and everything will be represented in your document as well. And you can also make indexes for PSI elements. For example, we use indexes for class names, for class full qualified names. So if we need to find some full qualified name, we just go to indexes and search through these indexes. So I want to show you a short demo how to implement some simple inspection. Imagine a situation when we need some name validator. For example, function name must start from fun, then uppercase letter, val for values, and var for variables. That's just imaginary situation because code will not look very well. So let's do it. I created some stub class, and also I added some information that we want to add inspection to plugin. It's very simple, actually, so I don't want to tell you a lot about it. We have XML element where we can add any extension, any entry point to IntelliJ API. There are different entry points, but one of them is local inspection, so we can add some inspection to Scala editor. So how we can do it right now? Just extends abstract inspection. With some ID, analyze name inspection and name, analyze inspection. Then we need to implement action4 method, which requires some partial function. So let's start. We need to check function name style, so we need to check C function PSI element. So let's function. Also, we need it's only in such case when function is class member. So we need to check that function containing class is not null. And then we can we now generate some general stuff for some prefix, some elements, and holder. Holder we need to pass it here because it's a class which collects information about bad code. So let's create method from usage.
What did you push to generate the method from the name?
I just invoked a quick fix. It's alt-enter.
Right.
Create method, check name. So it's here prefix, element. We need C named element because I wanted to make this function to make it more general, not only for functions, and holder. And we don't want to return anything because this method with side effects. So what we need to do firstly is to check that this element is in sources, because of course libraries will not have such name convention. So we can check is in source. I just invoked global completion for this method because I don't remember where to find this method. So I invoke till x. I can pass here. And now we need to check that name doesn't match to our prefix convention. So if we need is okay. If element name matches prefix a, z, and some other stuff. Okay, not. And also let's introduce variable here. So this is the case when we want to show inspection for this code. Now we need to just put this information to the editor and to the appropriate quick fix how to fix this thing. So just put holder, register problem, and now we put element. So element, we don't need to highlight all function, just name identifier. So we need to highlight it, show it here. So description is like name doesn't match to prefix and prefix. And what we need more is highlighting type. Here I can use smart completion for factory methods, generic error overworking. And also we need to add quick fix for our inspection. So here we add abstract fix, which also generates, implements methods to this new class. For this fix, we need to add name, which is rename element, and to add some element. Okay, so now we need to rename this element to proper name. So new rename processor. So now I can invoke smart completion to find project location, then pass element. New name will be prefix plus name dot capitalized, and some different stuff. Just run it. So quick fix will rename our name to prefix with capitalized name. Actually, it will not work for operator names, but I don't want to spend more time on showing, checking that this is not operator name. So let's take a look how it works. So just run debug IntelliJ IDEA. So currently we wrote it only for function, but we wrote a generic check name method, which we can extend for all other values or variables. Okay. It starts slowly. So you can see that it just works. Name doesn't match to prefix. We can put it here also, and for example, to fix all these problems with one action, fix all analyze elements. Here you can see that we've just fixed it right here.
Yes, yes.
I'm sure that it was simple to me because I prepared for this talk, so this actually will cost more time, but again, everybody can do it for yourself if you need some special business processes for your project. Also, of course, you can ask anything from me about API and your problems if you have it. Okay, so that was about Scala plugin sources, and I want now to go to third part. It's about roadmap of Scala plugin and Play plugin. Next thing is project configuration, which is pain point right now in Scala plugin. So we want to remove Scala facet from configurations. We want to add, to change it to just simple Scala library, where you can define library class path and compiler class path separately. So this library will be possible to share between different modules. So, and of course, we want to make better usability of initial project creation. So you just put some settings on project creation, and everything works right after project creation. So it will be better. It will have better experience for newbies. This is what we want to do in the nearest future, like a week or 2 weeks. Next thing is compilation. Currently, we implemented Zin compiler for external build system. We also want to try own dependency management for Scala to make it faster and to return possibility to compile single file. Of course, Zin compiler will be still available, but we also want our own dependency management, just to try new things, to make things faster, and to check if it will be usable for people for incremental compilation.
Have you considered using SBT for that?
No, we consider to use just raw Scala C, but with our own dependency management, which probably will be fast. Next thing we want is to do SBT integration to make it working for most SBT projects. Right now it works probably for half of SBT projects. So you can try a nightly build and to see if it works for you. So currently it's implemented in a way that you can import SBT project and to make automatic synchronization of your build and IntelliJ project. Also, we want to end SBT console inside of IDEA to run SBT task right from IDEA, and of course to bundle it to Scala Plugin. What about integration? I just said earlier that we want to integrate with Play2 plugin as well. We also want to do some infrastructure to support compiler plugins in IntelliJ IDEA, because currently compiler plugin writers must think about writing something I showed you about inspection. I mean, writing extension to Scala plugin, but actually we want to implement something simpler for them, so we can, in these cases, you will be able just put some small instructions and describe what you want from this compiler plugin. And probably to bundle these instructions to compiler plugin binaries, so IntelliJ will be able to read it from binaries and just to start highlight it in right way in editor. So probably this meta information will make possible to simplify usages of macroses if somebody use it. And other things we want to do is SSP support. Who actually use it right now? Nobody. Okay. This is different template engine than Play2 has. Probably it's slightly different. I don't want to tell it's better or not. So we want to implement it very soon. Other things is debugger, so better step over into. So like if you have 4 comprehensions, it's for GVM. It's of course it's when you do step over, you just go. You don't step into for comprehension, because it's just a different function call to some functions of like map or flat map. But we want to do it better in IntelliJ editor, so if you do step over, so it goes into the for comprehension. And okay.
How would that work? Would you present a little window of how things actually are, and then you could step through that? See what I'm saying? So the for comprehension really turns into other things, a sequence of filters and flat maps and things.
Just currently we're just waiting for changes in IntelliJ 13 API, so we can't implement anything right now because it's not possible. But after that, we will see how it works, how it will work, because we even don't thought a lot about it. Okay. Also, we want to do some performance improvements, because some projects are still slow with IntelliJ Scala plugin. And also we want to enable type error highlighting, which is, I think, almost all of IntelliJ users use it. So why not to enable it by default? It will be still available to disable it. For example, if you make some presentation and you don't want to have errors in editor, but it will be possible to, for example, for newbies, they will see error right after creating new project. So that's all what I wanted to tell you about IntelliJ. So thank you very much.
Thank you. Nice to meet you.
Nice to meet you.